This video is showing two Aeroqual VOC sensor heads plugged into the Series 200 monitor base. While these sensors are detecting the same gas, VOCs, this is a low range sensor which has a range of 0 to 25 parts per million, whereas this is the high range sensor with a range of 0 to 500 parts per million VOCs. The purpose of this video is to show why in a situation where the levels of VOCs are likely very low, you're going to want to go with the lower range sensor. It can be tempting to purchase the 0 to 500 range sensor even if you know you only have low levels of VOCs, because then it can feel like, well, at least all my bases are covered. But in the real world, it's better to go with a low range sensor when you're actually likely going to be measuring low levels of VOCs, and this video is going to show why. At the moment, I don't have any VOC gases that I've released into the air right around these sensors, but you can see that they're both reading 3. That's just, there's a small amount of VOCs in the ambient air of the area that I'm working with here today. And by the way, this is not a scientific experiment by any means. I am simply showing how the two different sensors act in the presence of low VOCs and why this one is better for low levels. If I open a Sharpie several inches away from these sensors and just let it sit there, it will emit low levels of VOCs. And so we're just going to watch how the two different sensors respond to that. So I'm uncapping it, and then I'm moving it about 10 inches off screen, and we will just watch how the two sensors respond to these low levels of VOCs. This section is cutting out the wait time between updates to speed up the video. A little bit of background information is that the low range sensor is updating every 60 seconds, whereas the high range sensor is updating every 30 seconds. This doesn't necessarily mean that the reading itself changes, but the calculations happening internally is 60 seconds updating every time with the low range and 30 seconds every time updating with the high range. I'm now going to put a cap on the Sharpie. So this is about as close as we're going to get to 0 with the setup that I have here, where I do have very low levels of VOCs in the background. So in conclusion, this video has shown how with the low range sensor, which goes from 0 to 25 parts per million, you have higher resolution, as well as the readings change more frequently because this sensor is more sensitive. Whereas with the high range sensor, the resolution is lower, and also the readings don't change as frequently with the fluctuating levels of VOCs.